Imagine, if you will, the vast silence of space, a canvas of endless black, dotted with distant stars like forgotten jewels in an ancient vault. It's October 3rd, 2025, and something extraordinary is unfolding near the red planet Mars. While the world below buzzes with everyday chaos, high above, China's Tianwen-1 orbiter, that steadfast sentinel circling the Martian skies, turns its gaze outward. Not to the rusty dunes or swirling dust storms it's meant to study, but to a fleeting visitor streaking through the cosmos, the interstellar object known as 3I/ATLAS. This isn't just any rock tumbling through space. Discovered on July 1st, 2025, by the ATLAS telescope in Chile, 3I/Atlas is the third confirmed wanderer from beyond our solar system, following in the enigmatic footsteps of Oumuamua and Borisov. But from the moment it was spotted, it carried an air of mystery. As it hurtled inward at a blistering 58 kilometers per second, astronomers worldwide held their breath. And on that fateful day, as it skimmed past Mars at a mere 17 million miles, close enough for a cosmic handshake, Tianwen-1 captured something that would send ripples through the scientific community. Picture the scene. The orbiter's instruments, designed for mapping Mars's ancient secrets, pivot ever so slightly. A quiet command from Beijing's control center retasks a camera, and in that brief window, it snaps a frame that changes everything. The object, once a faint reddish blur in distant observations, now glows with an ethereal green hue, a vibrant emerald shimmer against the inky void. It's not the passive reflection of sunlight on ice and dust. It's something more alive, more deliberate. The coma, that hazy envelope of gas and particles, pulses faintly, fluctuating in brightness with a rhythm that defies easy explanation. My heart races just thinking about it. The thrill of discovery, the chill of the unknown. This green glow, later confirmed by ground-based telescopes, like the Very Large Telescope in Chile, isn't from the usual suspects. Comets often turn green thanks to diatomic carbon absorbing ultraviolet light. But 3I/ATLAS. Its spectra show cyanide and nickel vapors dancing in the mix, with barely a trace of the expected molecules. No iron alongside the nickel either. A chemical oddity that whispers of origins far stranger than our neighborhood comets. It's as if this visitor hails from a stellar nursery billions of years old, carrying recipes from the galaxy's thick disk, where stars burned hotter and elements fused in ways we've only theorized. If this hooks you, like it does me, hit that like button and share this tale with a friend. Let's spread the wonder of the stars. Who knows, your comment below might spark the next big idea about what 3I/ATLAS truly is. As the data streams back to Earth, the excitement builds like a storm on the horizon. In Beijing, analysts at the Chinese National Space Administration pore over the telemetry, their faces illuminated by glowing screens. They expected the familiar, a reddish tint from organic dust, perhaps a faint tail trailing away from the sun. But what Tianwen-1 reveals is a transformation that defies textbooks. The comet's halo shifts almost frame by frame, from the initial reddish observations in July to the striking green as it nears Mars. Algorithms designed to filter solar glare can't account for it. This isn't mere sublimation, the gentle evaporation of ice under sunlight. It's a controlled sequence, the green intensifying with each rotation. Harvard's Avi Loeb, that tireless seeker of extraterrestrial clues, weighs in. This color change, combined with the anomalies, ranks it a 4 on my scale, worth watching closely. He's not alone. Forums buzz with speculation, from natural outgassing to something more engineered. Dive deeper into the emotion here, the awe of witnessing a cosmic chameleon. Imagine being one of those analysts, your pulse quickening as the spectra unfold. The green isn't uniform. It flickers, strobing every few hours, as if the object is breathing, drawing energy from the void. X posts from amateur astronomers capture the frenzy. Tail strobing like a heartbeat, 20% brightness spikes, one says. Another notes lopsided nickel glow, stronger toward the sun. These aren't random. They're rhythmic, synchronized with the comet's spin, estimated at 16 hours. And the chemistry? The infrared readings from Tianwen-1 show spikes in cyanide and nickel, narrow and sharp, unlike the broad emissions of natural thermal radiation. Temperatures? Not the scorching 5,000 degrees Celsius of fiction, but an anomalous heat signature nonetheless. Internal warming that's too efficient for solar flux alone at that distance. Cross-checks with Earth's observatories, like the Keck in Hawaii, confirm. Nickel vapors venting with surgical precision, mirroring patterns in human-made thrusters. Feel the weight of this moment, the global connection it fosters. From Chile's deserts to Namibia's eclipse chasers, people worldwide are united in wonder. If you're feeling that pull toward the stars, drop a comment. What do you think 3IATLAS is? Like and share to keep the conversation alive. Transitioning smoothly from the visual spectacle, let's delve into the invisible, the spectral data that paints a portrait of inner turmoil. Tianwen-1's spectrometer, repurposed in that pivotal October glance, captures jagged peaks across wavelengths. Analysts expected gentle curves from frozen water and dust. Instead, they get eruptions of energy, indicating rapid internal processes. The graph lights up with CO2 emission bands at 4.26 microns, the same as engineered plasma exhausts. But here's the twist. The ratio of CO2 to water is 8 times higher than any solar system comet, an outlier that screams foreign. As 3IATLAS spins every 16 hours, each surge aligns perfectly, ramping up smoothly before plateauing. It's not chaos, it's orchestration. Emotionally, this hits hard, the realization that we're peeking into another world's diary. Picture the young scientist in Beijing, double-checking calibrations, her breath catching as the anomaly holds. "This isn't random," she whispers. Global teams compare notes. Chile's Paranal Observatory sees intermittent green flickers. Japan's ALMA array detects faint magnetic scattering. Yet official statements remain cautious, echoing denials from NASA and ESA. The power output? Estimates from infrared data suggest surges equivalent to gigawatts, far beyond what a comet this size, nucleus under 1 kilometer, should muster. No outbursts or fragmentation like Borisov. Instead, stability amid activity. No non-gravitational push, despite outgassing. It's as if the jets balance perfectly, like a self-regulating system. This chapter energizes the narrative, building tempo with each revelation. If your curiosity is piqued, smash that like and share. Let's get more eyes on this cosmic puzzle. Flowing from the surges, we arrive at the chemical heart of the mystery, nickel. Decoded from Tianwen-1's packet, the spectra reveal nickel vapor lines, produced at temperatures no natural comet should achieve so far out. No iron pairing it, a missing iron paradox that's baffled experts. For planetary scientists, this means metallic material is vaporizing deliberately. Natural heating? Too weak. Outgassing? Too chaotic. The ratios mirror thruster tests from early Mars missions. Nickel alloys enduring extreme heat, venting with carbon dioxide and silica. Debate rages in China's aerospace circles. Is this thrust? Energy regulation? Loeb calls it anomalous evolution, suggesting absorption and release of solar energy. Emotion layers deepen here, the fear of the unknown mixed with exhilaration. Imagine families worldwide discussing it over dinner, kids wide-eyed at the idea of alien artifacts. Relatable storytelling. In India, a student sketches the comet. In Brazil, a teacher uses it to inspire STEM dreams. Calls to action. Comment your theories below. Thrust or natural. Like if this chapter thrilled you, share to ignite global dialogue. The cosmic stage is set, and the rhythm of 3IATLAS begins to feel like a heartbeat echoing across the void. Picture the scene in Beijing's Aerospace Flight Control Center. Rows of analysts hunched over screens, their faces glowing with the soft blue light of data streams pouring in from Tianwen-1. As they plot the thermal curves against time-stamped imagery, a pattern emerges, a pattern so precise it sends a shiver down the spine. Every surge of heat, every flicker of that mesmerizing green glow, aligns with a cycle of exactly 16 hours, 12 minutes, and 7 seconds, matching the comet's rotation to the second. This isn't the chaotic sputter of a natural comet, where ice bursts randomly under solar heat. No, this is orchestrated, deliberate, like a symphony conductor raising and lowering the baton with mechanical precision. Imagine the weight of that moment. The realization that you're not just observing a rock, but something that seems to think. The data shows the heat ramping up smoothly, plateauing, then declining in perfect symmetry, like a power cycle in a fusion reactor. It's mesmerizing, almost hypnotic. The lead analyst, a young woman named Li Wei, pauses, her fingers hovering over the keyboard. "This isn't sublimation," she murmurs to her colleague, her voice barely above a whisper. "It's regulation." Her words carry the weight of a revelation, the kind that keeps you awake at night, staring at the stars, wondering what else is out there. Now, let's dive deeper into the science that's got the world buzzing. When the team filters the data into frequency space, the thermal curve reveals harmonic overtones. Secondary peaks spaced so precisely, they could be plucked from an engineer's blueprint. These aren't the messy signals of cosmic noise. They're clean, like the oscillations of a plasma engine firing in a lab. Tianwen-1's magnetometer, though not built for deep space work, picks up faint disturbances during each surge, a whisper of electromagnetic activity synchronized with the green pulses. It's as if 3IATLAS isn't just hot. It's alive with energy, manipulating the very fabric of space around it. The emotional layer here is profound. Think of a child in rural Kenya, peering through a borrowed telescope, catching a glimpse of this pulsing green star. Or a retiree in Canada, refreshing X-posts to read the latest theories from amateur astronomers. This isn't just data, it's a global awakening, a shared quest to understand. The intensity of the pulses grows with each orbit, correlating with spikes in solar wind density. It's as if 3I/ATLAS is sipping from the sun's breath, absorbing energy, storing it, and releasing it in quantized bursts. Avi Loeb, ever the visionary, calls it a timeline of activation, as if the object is waking up, stage by stage, reflection, absorption, ignition, and now regulation. His words echo across X, where users post, "It's like a cosmic engine warming up. And is this thing charging?" But the implications? They're staggering. If this is self-regulation, we're not looking at a comet anymore. We're looking at something that responds to its environment, like a creature adapting to its surroundings. Picture yourself standing under a starlit sky, feeling small yet connected to this mystery. It's a call to wonder, to question everything we thought we knew about the universe. So, let's keep this energy alive. Hit that like button if this pulse quickens yours. Drop a comment. Could this be a natural phenomenon or something more? Share this story with someone who loves the stars as much as you do, and let's keep the cosmic conversation blazing. The tempo of our tale accelerates as 3I/ATLAS defies one of the oldest rules of celestial mechanics. Comets, those icy wanderers, are supposed to lose mass as they dance closer to the sun. Their surfaces bubble and crack, spewing gas and dust into luminous tails that trail across the sky like cosmic brushstrokes. But 3I/ATLAS, it's rewriting the script. Observatories from Chile's Atacama Desert to Japan's ALMA Array are picking up something impossible. This object is gaining mass, growing heavier as it journeys through the inner solar system. Picture the scene at the Vera C. Rubin Observatory, where astronomers huddle under the starry Chilean sky, their breath visible in the cold night air. Radar echoes from 3I/ATLAS reveal a density increase that defies logic. When it first entered our neighborhood in July 2025, its mass was estimated at 10 billion tons, a hefty but typical figure for an interstellar comet. By mid-October, as Tianwen-1's data pours in, that estimate triples to over 30 billion tons. The math doesn't add up unless the comet is accumulating material, pulling in cosmic debris like a gravitational vacuum cleaner. It's not shedding, it's feeding. The emotional weight hits hard. Imagine a physics professor in Mumbai, scribbling equations late into the night, trying to make sense of this anomaly. Or a teenager in Brazil, sketching 3I/ATLAS in her notebook, dreaming of a universe where objects don't just drift, they thrive. The spectral readings offer a tantalizing clue. Alongside the nickel vapor and CO2 spikes, Tianwen-1 detects charged silicates and magnetized dust grains spiraling toward the nucleus. These particles, which should be repelled by solar wind at 58 kilometers per second, are instead drawn inward, vanishing into the comet's glowing green core. It's as if 3I/ATLAS is weaving a magnetic net, capturing dust and compressing it in ways we can barely fathom. Chinese physicists, working in hushed tones behind closed doors, propose a radical idea: electromagnetic confinement. They suggest 3I/ATLAS is generating a localized magnetic field through its rhythmic energy surges, pulling in interplanetary dust and possibly fusing it for energy. This isn't just a comet, it's a self-sustaining system, a cosmic organism that metabolizes the raw materials of space. The concept echoes theoretical astrophysics. Think von Neumann probes, hypothetical machines that roam the galaxy, harvesting resources to fuel their endless journeys. Could 3I/ATLAS be such a marvel, a relic from a civilization long gone, recharging as it travels? The global reaction is electric. On X, posts explode with hashtags like #3IATLAS alive and #cosmic feeder. A South African astronomer tweets, "It's not disintegrating, it's growing." What are we even looking at? The idea that this object might be sustaining itself in the vacuum of space ignites imaginations worldwide. Families in Mexico discuss it over dinner. Students in Tokyo debate it in classrooms. It's a story that binds us, from the deserts of Namibia to the fjords of Norway, in a shared quest for answers. Feel that thrill? That's the pulse of discovery. If this chapter has you hooked, smash that like button and share this tale with a friend. Drop a comment. Is 3I/ATLAS a natural oddity or a cosmic machine? Let's fuel this global wonder and keep the stars within reach. Now, let's pull back the curtain on one of the most haunting discoveries yet. Tianwen-1's instruments, built for Mars' dusty plains, were never meant to probe the deep cosmos. Yet, as 3I/ATLAS pulses with its green glow, the orbiter's sensors pick up something extraordinary: faint oscillations rippling across its communications band. These aren't random glitches. They rise and fall in lockstep with the comet's 16-hour energy cycle. Picture the mission engineers in Beijing, their eyes widening as they realize they've stumbled onto a magnetic envelope, a thin, stable field surrounding the object, stretching thousands of kilometers into space. This isn't the chaotic turbulence of solar wind or the fleeting magnetism of a comet's outgassing. It's structured, repeating in evenly spaced modulations, forming a lattice of alternating polarities. Imagine a cosmic spiderweb woven with electromagnetic threads, shimmering in the void. The Chinese National Space Administration runs simulations, and their best model points to a rotating magnetic core, an internal dynamo energized by electrical currents, deep within 3I/ATLAS. Natural comets might spark weak, unstable fields during violent outbursts, but this field holds steady for weeks, amplifying with each green pulse and subsiding into silence between. The emotional stakes are sky high. Picture a young engineer in Shanghai, her hands trembling as she presents the findings to her team. "It's not just a field," she says, her voice steady despite the butterflies. "It's a shield." Some theorists propose it protects the comet's core from solar radiation and micrometeoroids, explaining how it retains mass against the sun's relentless push. Others argue it's a collector, trapping charged dust to fuel the object's mysterious hunger. Either way, it's a marvel, a cosmic fortress or a net cast wide to gather the galaxy's crumbs. Globally, the discovery resonates like a chord struck across cultures. In Nigeria, a street vendor listens to a radio broadcast about the comet, wondering if it's a sign from the heavens. In Iceland, a poet writes of a green-hearted wanderer, weaving its own destiny. X buzzes with theories. Magnetic shield equals alien tech, one user posts. Another shares a sketch of the field, captioned, "It's like a force field from sci-fi." The data, though limited, paints a picture of something not just surviving the void, but commanding it. This chapter is a turning point, a moment where science meets wonder. If your mind is racing, hit that like button and share this story. Let's spread this cosmic mystery far and wide. Comment below. Is this a shield, a collector, or something we can't yet imagine? Keep the energy alive. The plot thickens, and the world holds its breath. For 2 weeks, the Tianwen-1 team works in secrecy, their findings too explosive to share. The green pulses, the magnetic envelope, the impossible mass gain, it's all locked away, deemed too sensitive for public eyes. But in the digital age, secrets are as fleeting as stardust. On October 14th, 2025, a 14-megabyte file appears on Weibo's Science Watch, tagged only with T1A. Within hours, it's mirrored on global forums, downloaded by thousands of amateur astronomers and curious minds. Picture the chaos: a grainy image from Tianwen-1's optical payload, time-stamped 0302 UTC, October 14th, 2025. Against the black void hangs a green sphere, wrapped in concentric rings like ripples around a magnetic pole. A faint filament tethers a smaller elliptical object to the main body, shimmering between visible and infrared light. The metadata caption reads, "Frame 119, internal activation." It's not crystal clear, but it's unmistakable. A snapshot of something alive, pulsing, responding. The file includes telemetry logs, infrared scans, and an EM feedback entry, a 22-second delayed echo, as if 3IATLAS sent a signal back to the probe. The emotional impact is seismic. Imagine a college student in London, scrolling X late at night, stumbling across the leak. Her heart races as she shares it, typing, "This changes everything." The internet erupts. Western observatories verify the image's coordinates near Mars' orbital plane. Spectral peaks at 4.26 and 7.8 microns match Tianwen-1's CO2 and nickel readings. The EM feedback? It's too precise to fake, with hexadecimal timestamps aligning with the orbiter's clock. A retired ESA engineer speaking on a podcast says, "That's flight telemetry, not Photoshop." Something out there answered. In China, cyber authorities delete the file within hours, but the damage is done. The Chinese Academy of Sciences calls it a malicious fabrication, but encrypted chats among scientists tell a different story. Younger researchers push to publish. Veterans fear geopolitical fallout. Globally, the public isn't waiting for official word. X posts flood with hashtag 3IATLAS leak, with users from Brazil to Japan dissecting the data. 22-second delay equals handshake signal, one asks. Another posts a spectrogram, noting, "This looks like a reply." This is humanity at its curious best, united by a shared quest. Feel that rush? Smash that like button and share this with someone who'd geek out over it. Comment. Do you think 3I/ATLAS responded to Tianwen-1? Let's keep this global uproar alive. The leak ignites a firestorm, and the world's space agencies scramble to contain it. Within 48 hours, NASA, ESA, and JAXA issue identical statements. No verified evidence supports claims of anomalous emissions or self-activation in 3I/ATLAS. The synchronized wording, echoed across 3 continents, screams coordination. Behind closed doors, it's crisis mode. Meetings stretch late into the night, with analysts poring over the leaked data, their coffee growing cold. Picture a NASA scientist in Pasadena, her brow furrowed as she compares the Tianwen-1 frame to Hubble's latest images. The green glow, the magnetic scattering, it's all there, faint but consistent. Yet the official narrative holds firm. Instrumental echo, NASA claims. Ionized dust reflection, says the European Southern Observatory. But the public isn't buying it. On X, independent astronomers overlay spectra, confirming CO2 and nickel lines. A former JAXA engineer posts, "The 22-second delay isn't noise." It's a response. The emotional core is universal, the hunger for truth. Imagine a teacher in Argentina using the leak to spark debate in her classroom, or a retiree in Russia emailing his old astronomy club saying, "We're not alone in this." It's a story that transcends borders, uniting us in wonder and skepticism. The narrative crescendos as 3I/ATLAS approaches its closest point to the Sun on October 29th, 2025. The solar system's testing ground, the region near perihelion, is where comets either shine or shatter. Most would crack under the Sun's glare, their ices boiling away in chaotic jets. But 3I/ATLAS. It defies the odds, growing brighter, bolder, as if reveling in the spotlight. Imagine astronomers at Chile's Paranal Observatory, their telescopes trained on the comet as it nears 1.1 astronomical units from the Sun. The green glow deepens, pulsing with a rhythm that feels alive. Then, in a single 16-hour rotation, the light spikes tenfold, a surge so intense that detectors shut down to avoid damage. Infrared readings estimate an energy output of 50 gigawatts, enough to power a small nation. Tianwen-1, still watching from Mars, catches the tail end. A burst of magnetized plasma streaming outward, particles aligned in perfect symmetry, like exhaust from a thruster. The emotional stakes soar. Picture a family in Australia, gathered around a laptop, gasping at real-time telescope feeds shared on X. "It's moving on purpose," the father says, his voice tinged with awe. The plasma jet isn't random. It's directional, perpendicular to the comet's path, suggesting a course correction. NASA's Jet Propulsion Laboratory confirms a velocity shift of 1.2 kilometers per second, small but precise, stabilizing 3I/ATLAS against the Sun's gravitational pull. The energy matches the thermal surge, as if the comet chose its trajectory. Avi Loeb, speaking at a virtual conference, calls it the smoking gun. Color shifts, magnetic fields, these could be natural. But a deliberate maneuver? That's not a comet's playbook on X. Users post animations of the jet, captioned, "Is this a spaceship?" The global buzz is palpable, from cafes in Paris to observatories in South Africa. Even skeptics pause. Nothing natural explains this precision. This is the moment where wonder meets possibility. If your heart's racing, smash that like button and share this cosmic drama. Comment: is 3I/ATLAS steering itself, or is this nature's trick? Let's keep the world watching.